Hello, in this video we are going to try to write an NPAT or y equals mx plus b formula and create a graph. So we are starting off with data, and already completed for us are the change values here. And let me go back and get my pen. Change values here. And we remember that change values would be to take y2 minus y1. And the thing I notice about those change values are that they're not constant. And so because of that, I know that it is not linear. And so going back here, that means the y equals mx plus b formula is out. I need to create the NPAT formula. So the NPAT formula comes when the ratio, and we see the ratios here, are constant. So these are constant. And that is an indication that we are working with an exponential. So when we reviewed this, we reviewed that n is the same as our y values, so n equals. P is our start, and we know that the start is when time is 0. So I look in my data, and I see here is at time is 0. The start is 5, so I put that in. The A, we know, is the growth or decay factor. And we had noted that it is the y2 over the y1 value. And so looking at the ratios in my chart, I see that that is 32 and t is the time. Now, the truth is I don't have a good equation, but based on what I've learned so far, it seems like a good equation. So I'm going to go on to the next step of creating the graph. And in doing that, we're going to come back and we're going to revise this equation because we truly don't have a good answer yet. So I'm going out to my graphing calculator. And in my graphing calculator, the first thing I want to do is put in the data. So I'm going to go to Stat, Enter to Edit. My list 1 and list 2 both need changed from what they previously were. So I'll go up and hit Clear, Enter, over here to list 1, up, Clear, Enter. And so my list 1 is my x values or time, which were 0, 2, 4, 6. 0, 2, 4, 6. And my list 2 values were 5, 160, 5,120, and 163,000, huge number here, 840. All right. In your content guide, you were told to make a graph that just goes up for the first 4 hours so that we don't need to graph that really big number here at 6. So when I set up my graph, I'm looking for my list 1, my x values to go 0 to 4. I might go to 5 to give myself a little room. And I'm looking at list 2, so my y values need to go above 5,000. I'm going to pick 6,000. So my window, 0 to 5, looks good. And my y, 0 to 6,000. Lastly, I'm going to go to my y equals, clear out the formula I have from a previous problem, and make sure my plot 1 is turned on, which it is because it's in the dark box. And so I hit graph, and I see my data points, and it's only 3 data points, so it's kind of hard to see the shape of them. But I clearly see that the first 2, the slope is, they're almost like horizontal, and then it really goes up from there. So I can see that it does not have constant slope. And even if I would just connect these 3 points, I could see a concave up curve, which is exponential. So back in our PowerPoint, we wrote what we thought the equation was, and we thought it was 5 times 32 to the t power. So in my y equals, I'm putting 5, parenthesis 32, end parenthesis to the x power. And I'm going to hit graph. And I see that I get this concave up curve. It's an exponential curve, but it definitely is not hitting my data points. And what I see happening is like it's as tall as my last data point when it's at the second one. And it's as tall as the second one when it's at this tick mark 1. So it's kind of the rate curve, but what it did not account for is that the time did not go up by 1. And so we had talked about this with a previous example, and that time is our exponent, and we have to account for how time is jumping. And in this case, this jump is going up by 2 hours all the time. So all of these are going up by 2. So this 32 is for 2 hours. And so I have to divide my time in half to get the jump that would be for 1 hour. And that's why when I looked at my graph, if I took everything and doubled it, it looked like it would work because I have to change that time. So I'm going to go in to my y equals, over here to my exponent, and put in a divide by 2. Now, if you have an older calculator where you don't have an exponent font, you are going to need parentheses to pull that off. And so now I'll hit graph again. And this stretched my graph out because it stretched the time out. And I now see a graph, a clear concave up curve that actually goes through those data points. So we have this time adjustment here. And we are going to get into that more as we go through the lesson. But we have our first one, time adjustment. They are divide by 2 because the hours were going up by 2. When I look at my graph, this was hours, 0 to 4, 0 to 6,000. We actually had gone up to 5 here, even though our data only went up to 4. Our graph was nearly horizontal for a long time and then curved up quickly. And it did hit our data points here, here, and at the start.